Okay, a little lighting issue right now. I look nice and well lit, I think. I think this is okay lighting for me. However, the board, not so much. Gotta make sure I never use the screen again. Um, Section 5.1, yay! We are so close to the halfway point. I am so close to the halfway point. You are a little far from it. That's okay. We are in the middle-ish of October, and the air is getting crisp. Okay, your air will never get crisp. You don't know what crisp air is there. But here, the air is starting to get a little crisp. I hope that's what it'll be by the middle of October. It certainly isn't right now. Right now, we are in a hot, tropical summer. But that's okay. This too will pass, along with all the many mosquitoes we've been plagued with. Because it's so hot, got the hair up again. You're gonna probably see that a lot. It gets hot underneath these lights. So this is when we talk about all the different special things about triangles that'll work with almost any kind of triangle and with some special triangles. One of the special triangles we have to discuss is isosceles triangles. So when you have isosceles triangles, it has some various parts. You need to know what they're called. We have vertex angle, which is the angle that joins the two legs, which are the two sides that have to be congruent. So the vertex angle is the angle in between them. The base angles are the angles that actually touch the base. The base is the one that's across from that vertex angle, or the one that is not one of the two matching legs. Now, it is possible to have a base that is the same side as a leg. If that's the case, then it's an equilateral triangle, which means it's also equal angular, which means all your angles are going to be congruent and all your sides are going to be congruent. We're not talking about those kind today. So when you have an isosceles triangle, you have to have two sides that are congruent and you have to have two angles that are congruent. And the sides that are congruent are always opposite the angles that are congruent. That's the way it works out. It's convenient, I promise. That's the isosceles triangle. This is a special thing about isosceles triangles. So when the vertex angle, in that case, it's this one because I told you this was the base, and those two are the sides that are congruent. Something you need to be careful about, base doesn't mean it's on the bottom. It very rarely is actually on the bottom. That's one of the things they try to trip you up with all the time by making the base not be on the bottom so that you'll think something else is the base and you'll get the problem wrong. Don't fall for that. Don't fall for that. So when you have an angle bisector of your vertex angle, in other words, when those two angles are congruent, then that means that this will have to be a right angle, which makes it a perpendicular, and incidentally, a perpendicular bisector. The reason is, we just said all base angles are congruent. So that means that they have to be congruent. So if they're congruent and these sides are congruent and they're congruent, then by angle side angle, these two triangles must be congruent, which means these angles have to be congruent and these have to be congruent. And it just so happens that that always forms a right angle. We'll get to the reason why a little bit later on. It's in there, I promise. It's another theorem you're going to have later. But for right now, just knowing this one will get you through. Now, I wanted to go over some of the problems that are in the classwork section. This is not your classwork for the day. This is going to be what I go over. But I just wanted you to know where I was getting them from. So they are located on page 176. I'm going to go ahead and write them on the board. Hey, look, they're going to be there in just a second, like that. I'm just saying it can happen. But it's problems 7 through 11. And then you're going to have practice exercises for your classwork and your homework today. Just wanted you to know. Okay, I'm serious. It's going to happen just like that. Told you. It happens all the time. Don't know why you don't get used to it by now. Okay, so these are the problems. You can pause it and try it and see how you do, and that way you'll know whether or not your homework and classwork will go kind of quickly, or whether or not you're going to struggle. Just a suggestion. Okay, so for number 7, they tell you the measure of angle phi for this particular problem, the measure of angle S is 50 degrees. They want to know what R and T are, and we can tell that R and T are our base angles because RT is our base. We know that because it's not marked with congruent sides. So since this is our base, that means our base angles have to be congruent, which means that these 3 angles, since they make up a triangle, big triangle, but a triangle, since they make up a triangle, they have to add up to 180. So I can take my 180 and I can subtract the 50 degrees from angle S, and that leaves me with 130 degrees to equally spread between those two, and 130 divided by 2 equals 65. I can do it in my head. It can happen. So 65 degrees is how much the measure of angle R is and the measure of angle T. Now I'm going to erase that because we're going to a different problem. But notice I didn't do any fancy algebra. I just did the stuff in my head. So this is the big thing you have to understand about where they're taking geometry now. Back when my mom learned geometry, it was all proofs. Everything was a proof. Everything. She only wrote proofs. That was it. Geometry was all proofs. So when I came along, geometry was about, I'd say maybe 30% proofs, and the rest of it was being able to do that. Well, now they don't do any proofs in geometry. Most high school kids never see a proof, don't know what a proof is, and couldn't do one if they had to. Whereas you are being forced to, but you have a background that will thrive with proofs, whereas most students don't get that logic background. They don't know about inverses and converses and doing negatives of statements. All they know is, well, I know that's got to be true because of this, so I'll divide it by 2 and I get that. That's what they know. So they learn the procedure and they learn the information, but they can never write it in a formal proof, which incidentally will mean they will never make it to be a geometry teacher, because geometry teachers have to go through schools that make you do proofs. I mean, a lot of proofs. But anyway, neither here nor there. They won't get my job. That's all I'm saying. Not worried. I got some job security now. So most kids would just be doing that, whereas we're teaching you how to do proofs and do that. Not everything has to have an algebra layout. Some of it can be done in your head, and that's fine, good, and wonderful. Won't hurt my feelings a bit, because I can do it in my head too. Just saying. So for number 8, they tell you the measure of angle SUV is X, and they want you to find this. Well, since this is across from that, and we know that this is its own little isosceles triangle, that means the measure of angle SVU is also X. So now this has to be 180 minus those two. So it's going to be 180 minus 2x. Didn't say it was going to be hard. For this one, the measure of angle R is 5x plus 10. The measure of angle T is 3x plus 30. They want you to find the measure of angle S. Doing the exact same format. Now they gave me a little bit of something I can build an equation with. So I know that 5x plus 10 has to equal 3x plus 30. I'm going to go ahead and figure out what x is. You don't have to do it this way. As long as you get the right answer, we're good. Because, like I said, I know what you're doing. So, I'm going to subtract 3x from both sides. That'll leave me with 2x plus 10 equals 30. Subtracting 10 from both sides, 2x is equal to 20. Divide both sides by 2, x is equal to 10. Now that I know that x is equal to 10, that means that 5 times 10 is 50, plus 10 makes this angle 60. 10 times 3 is 30, plus 30 makes this angle 60, which is good, so we're probably right. So if this is 60 and that is 60, then that one must be 60. Which means it's an equilateral triangle, but still isosceles, because equilateral triangles are also isosceles. So for number 10, they tell you different ones. They give you R and they give you S. Well, R is down here, but S is not the same as R. But we still know that R and T are the same, and we know that they all have to add up to 180. So I could say that 2x plus 10 for my R plus my T, which is 2x plus 10, because they have to be the same, plus my x plus 10, all has to equal 180. 2x plus 2x plus x is 5x. 10 plus 10 plus 10 is 30. Has to equal 180. Subtract 30 from both sides. 5x equals 150. Divide both sides by 5. X is equal to 30. That is not your answer, but I know you know that. You've been in my class too long not to. So if x is 30, we need to figure out what t was. We said t had to be the same thing as this. So 30 times 2 is 60, plus 10 makes the measure of angle t equal to 70 degrees. I won't take off if you don't put your little degree sign, generally speaking. But I need you to know it's supposed to be there. How about that? If isosceles triangle JKM has a base of JM, name the congruent size and the congruent angle. They didn't give me a triangle. No picture here. That means I need to draw a picture. I really need to draw a picture. Doesn't matter what your picture looks like, as long as you mark it like an isosceles triangle, it is an isosceles triangle. So this is my isosceles triangle. It says that the base is JM, so I know this has to be my J, and that has to be my M, which means up here must be my K. Now that I got something to look at, I can list off everything. I can tell you what the base is, I can tell you what the legs are, I can tell you what the angles are, all of it. So I know that my size, JK, is congruent to MK. And I know that angle J is congruent to angle M. Just that quick. Which means the distance of JK and the distance of MK are the same, and the measure of angle J and the measure of angle M are the same. So, nothing hard, kind of quick. I know you like it that way. I don't blame you. I probably would too. Classwork and homework. Not hard, kind of quick. In my opinion. So, page number 177. Classwork numbers 2, 6, 10, 15, and 19. And then homework numbers 4, 8, 13, and 17. Okay. You'll see me tomorrow. Bye.